The common ion effect can suppress solubility if a substance is dissolving and producing ions of a certain type, and that type of ion is already present in the solution. It's going to suppress the dissolution of the substance. It's a simple application of the ice table, but we just want to quickly give an example of that. So here's mercury 1 chloride. Now mercury 1 is that strange ion. It's actually 2 mercury atoms with a +2 charge on it, so each mercury has an oxidation state of 1. The ion is Hg2, 2+. That's the chloride of it, Hg2Cl2. And the questions are, what is the concentration of the mercury 1 ion in a saturated solution, and what is it in a solution that already had 0.03 molar sodium chloride? So that chloride would be a common ion. A is an easy question. You probably can do directly without even making an ice table, because you know that when a compound dissolves and forms one of one kind of ion and 2 of another, the ice table leads you to the conclusion that KSP is equal to 4x cubed, where x is the solubility of the substance. But let's go through it. Here's the ice table that you would get. Zeros initially. Change is x and 2x for chloride, and those are the equilibrium concentrations, x and 2x. Put that into the expression for KSB, and sure enough you get this 4x cubed coming out of it, and it's easy to solve. Take KSB, divide by 4, and take the cube root. And you find that the stuff is not very soluble, okay? So it's 6.7 times 10 to the minus 7 moles per liter solubility for mercury 1 chloride, okay? But now let's look at it with some chloride already present. You're trying to dissolve it in a solution of 0.030 molar NaCl. And that just changes the initial line on the ice table, okay? All you have to do is put it in 0.030 and then carry on. It's still x plus 2x, and place those values into KSP just as before. Now comes the x is small approximation. Saves us a lot of work here, but think about it. The x before in part A, x was 6.7 times 10 to the minus 7, okay? Now we expect it to be even smaller because we know Le Chatelier's principle. We know the presence of that chloride is going to suppress the dissolution of the mercury 1 chloride. So really 2x compared to 0.030 is nothing. It'll be an extremely tiny number. So we make that approximation, and then it's easy to solve. Take 1.2 times 10 to the minus 18, divide it by 0.030 squared, and that's your x, and it turns out to be 1.3 times 10 to the minus 15. Clearly x really is small, and so we don't have to do much checking there, and it's an extremely tiny number. So the lesson from this is, again, the presence of an ion already in solution is going to suppress the dissolution of a substance that contains that ion. And that's the common ion effect in action.